Today we're going to discuss interval inversions, and through that understand how triads and seventh chords can invert as well. So let's go back and review very quickly what an interval is. Interval is two separate pitches, either simultaneously or successively, and the distance between them. Because these are three steps away from each other, F sharp G A by letter A, F sharp G A, that means it's the top type of third. And remember that we learned to designate what type of third it is by two ways. One, counting the half steps, F sharp to G, G sharp, G to G sharp to A. 3 would give us a minor third, but also to use key, that in the key of F sharp minor, that is a diatonic third, therefore it is a minor third. So we have that quality that we can use the quality of the interval. We can use the mode to help us learn that. Now we're going to learn something very important today of how harmony works, about the whole system of harmony. Harmony makes an equivalence that is in some ways very logical, but in some ways it's a little arbitrary, and it's pretty easy to explain because we use letter names. A, B, C, D, E, F, G. A is how we indicate our musical staff. A, B, C, D, E, F, G, and then we start with A again. The very nature of the system indicates that A is a repetition, and we know from previous videos that repetition is actually a 2-to-1 ratio in terms of hertz, in terms of frequency, with the original. That this pitch is about 444 cycles per second, and this is about 880 cycles per second, 2-to-1 ratio. Now, in our theory, we say that A and that A are not exactly the same thing, but they're pretty close. They're related. They are bunched together. They are grouped to give them the same designation. And we use a word in theory called pitch class to indicate all the possible letter names of that particular value. For example, my pitch class A would indicate all those, A4, 5, 6, A2, A1, A0. All of that would be a pitch class A. Pitch class A. So this is something we do in our system. It's very important to understand. We, for purposes of making harmony work, make an equivalence. There's a pitch class A, which is all A's. All A's. Now, having said that, let's take a little interesting trip here with our interval of a minor third. Here is my minor third. Minor third is that close distance of the 3 with the F sharp below and the A above. Now, what I'm going to do is to transpose that lower pitch up an octave and keep that higher pitch the exact same. So now my lower pitch has gone above my my higher pitch, but it's still here. And this is the important part. This is pitch class F sharp, and this is pitch class F sharp. This is pitch class A, and this is pitch class A. I've gone from F sharp 3, A3 to F sharp 4, register A3. But I have not changed my pitch class. Now listen to the two intervals, or the two intervals I have there. One, the first one, and the second one. Listen again. Now, they aren't the same thing, are they? But they have a real strong relationship, don't they? Because the pitch classes are the same. We hear the same pitch class, but the distance between them is different, isn't it? You can hear it sounds different. It's similar, but not quite the same quality. In fact, if we look at the second interval and form our technique for learning this, we have, what is the sixth? A, B, C, D, E, F sharp. It's some sort of sixth. And that F sharp would not be diatonic key of A minor, but in the key of A major, which has 3 sharps. That would be, so that is a major sixth. So instead of having a minor third, I have a major sixth there. Here's my minor third and my major sixth. Now, they don't sound the same, but they sound awful similar, don't they? They sound quite a bit similar. The difference is the distance between them at this point has been altered because we have transposed the lower pitch to the upper pitch by 1 octave. We refer to this as inversion. Inversion is where we reverse the order of the pitches, which is highest, which is lowest, usually by transposing one up and the other and leaving the other the same. Do another one. In this case, I'll take it down. That is an inversion as well. Inversion means in either direction. In this case, it's B flat 3, and D4. Now it's D3 and B flat 3. And that is so that we have inverted one pitch, the interval, we have turned it upside down by transposing one or the other of the intervals. The inversion is very important because although it is not identical, harmony treats it that way. Harmony treats it that we have the same thing in terms of larger structures and intervals. Chords treat the harmony, those two intervals, as one type of harmony. So we need to know our intervals and their inversions. That the inversion of any given interval, any given interval has with it its inversion. Same pitches, different register for one of those pitches. And it can be even different, completely different registers, not just an octave, but many as well. Now, so we have to understand and be aware that any given interval has an inversion of that interval, which has the same pitch classes, but in a different register with the order of which is higher, which is lower, reversed. This is important for harmony. When we understand how that works, we understand then how chord inversions works and how we can associate harmonic motion not by the inversion, but by the root movement. So it's important for us to learn this. Now there is a difficult and an easy way to do this. The difficult way to memorize or know your inversions is to stare at the poor thing and say, okay, let's see, that's a fourth, D, E, F, G, 4, and it's diatonic in both D major and D minor, so that's a perfect fourth. Okay, now I'm going to invert that by putting the lower pitch an octave up. Now they are inverted. This is inversion. That's now a fifth, G, A, B, C, D. And since it's diatonic in both G major and G minor, it's a perfect fifth. I can do it that way. And I just spent a whole lot of time just to be able to determine its interval and the intervals and its inversion. However, there's a very simple formula to this. Very simple formula that makes it a lot easier. The simple formula is everything equals 9 in the inversion, and it's the original and its inversion all equal 9. So if I have a third, its inversion will, the original plus the inversion will equal 9. 3 plus 1 equals 9, 3 plus 6, and indeed that's a 6. So everything equals 9 with the exception of the unison. The unison you have to pretend to 1 and a 0. Then it makes sense, but if I have a second, a seventh, if I have a fourth, it'll be a fifth. If I have a seventh, it'll be a second. So that's my formula. Everything equals 9 except for the octave unison. Now, the other one is another easy formula. If my interval is perfect, the inversion will automatically be perfect. Check it out. Here we have a perfect fifth. And indeed, that is a perfect fourth. So, perfect fifth always inverts to a perfect interval always inverts to a perfect. A major interval always inverts to a minor interval. Major third, minor sixth. Note again, 3 plus 6 is 9. My minor interval inverts to a major. Let's take a minor second here. Inverts to a major, in this case, a major seventh. So perfect inverts to perfect, minor to major, major to minor, minor to major. My augmented will invert to diminished. fourth. Fourth plus what equals 9? Fifth. And indeed, that is 5 steps away. This is an augmented fourth. And indeed, that's a diminished fifth. And vice versa. My diminished will invert to augmented. Diminished, that's a third. It's a diminished third. And inverted, that's a sixth. And that's an augmented sixth.